Hello everyone and welcome to another session on moving load. I am Surajit Ghosh and in this video I will discuss about various components required to define a moving load in STAAD and how to add a vehicle definition with wheel load and axle distance considering different type of vehicle and crane. In last video I have covered the basic of moving or time dependent load and why a moving load analysis is required for any bridge or gantry girder design. When a vehicle moves, position of the load change over time, which modify the member force and affects the member and connection design result. Among all possible load position, only few are critical, and it is very important that we find out the critical location which produce Worst effect in the supporting structure. If you want to know more, check my last video. To define a moving vehicle load, there are two steps. First, we need to add a vehicle definition with axle distance and wheel load. Then we can apply this load on the structure in any direction with fixed interval. Today, I will cover the first step, how to define a vehicle load correctly. Before going into the details, let's discuss what are the information required to apply this load. Assume a small vehicle with two axles like a car and it is in static condition. All four wheels are in contact with the soil or any supporting structure like a bridge deck or parking platform. From structural point of view, total weight of the vehicle plus live load is transferred to the supporting structure at 4 contact point of the wheel. This is what we called as wheel load, and this information is important for moving load definition. For structural analysis, we are converting this car to a load assembly with 4 vertical load component and wheel load intensity of each wheel along with longitudinal and cross-directional distance between these wheels are required for load application. All these details are provided by the car manufacturer. Also, wheel load and axle distance of few vehicles are available in the standard design guide. For India, we can follow IRC 6, and for America, vehicle details are provided in AASHTO code. For example, axle load and dimension of a 3-axle HS15 or HS20 type vehicle is provided in AASHTO code. Both longitudinal and center-to-center distance of the axle is mentioned here. When this truck moves, this static wheel load is applied at different location. Similar logic can be followed for a crane load. If we want to use the moving load feature for gantry girder design, then we need to define the crane wheel load and distance between the wheels. There are different types of EOT crane, and depending on the crane type and span, crane wheel load varies. There might be a single crane girder with hook, which is used for a small capacity crane, or multiple girders with trolley, which is common for medium to large capacity crane. Cranes might be supported on 2 wheels in each side or multiple set of wheels, and depending on the wheel number and crane arrangement, we need to define the load. For overhead crane, wheel loads might be different depending on the position of the load. When the hook along with load, trolley and other attachments move in orthogonal direction, that change the wheel load. Imagine a simply supported beam with a point load moving from one end to other. That will obviously change the support reaction for crane, which is equivalent to the wheel load. There are several other factors which can affect the wheel load, so it is very important that we consider correct wheel load for analysis, considering maximum capacity. Few empirical equations are available to calculate maximum static wheel load depending on the crane capacity and type. I will not cover that in this session. Consider this warehouse with longitudinal length 54 meter and cross-directional span 25 meter. A 20-ton overhead crane is supported on these gantry girders, and I want to apply this crane load as moving load on these members. For this, we need the crane wheel load, span of the crane girder, and center to center distance of the wheels. Maximum static wheel load of this crane is 160 kN and wheel distance is 3 meter. We need to add this under vehicle definition. For that, either we can use load definition page or use this vehicle definition option in the ribbon. In the vehicle definition window, 3 different options are available to define a wheel load. First option is generic, and we can use this either to define wheel load of any vehicle or a crane. We can provide a reference number for identification, width of the axle, which is center to center distance of the gantry girder, 24 meter. For any vehicle, this is the transverse distance between two wheels. If the width is 0, then the load is applied in a line like a cycle. Finally, we need to add the wheel loads of one side starting from the first wheel. For this crane, all wheel loads are same, and we can specify both wheel load as 160 kN. Note that positive load means it is acting in the downward direction. No need to provide a negative sign. Distance between two wheels is 3 meter. If there are multiple wheels, then we need to add other wheel load and distance as well. For example, consider this HS20 truck with 3 axle defined in AASHTO code. To add this truck load, we need to specify the width as 6 feet and wheel load as 4000 pound, followed by two 16,000 pound load. First one must be the load coming from the front wheel of the vehicle. Distance between the wheels are 14 feet and 20 feet in the direction of the movement. With this, wheel load of this truck is added for analysis. There are two other options. For AASHTO option, truck load specified in AASHTO code are available with prefixed wheel load and distance. We can use these options to directly add the wheel load. For example, we can apply same truck load using HS20 option. There are two optional parameters. First factor is used to scale the applied load. Using this, we can increase or reduce the wheel load. Like, we can increase the wheel load by 25% using a factor 1.25. Variable spacing for HS series truck as defined by AASHTO can be specified using the second input. In AASHTO code, distance between the rear axle is mentioned in between 14 to 30 feet. By default, the distance is considered as 14 feet, but we can modify using this variable. Finally, we can use an external file to define the wheel load and distance. I think this is the most useful option to define a crane or vehicle load. There is no specific file format. Normally, a text file is used to store the value. But all load and distance must be defined properly in the file. Else, program will unable to read the load data. We can add multiple vehicle loads in a single file. To add a vehicle load, we need to specify the reference or name of the load at top, followed by the wheel load information starting from the front wheel, similar to the UI option. Then distance between the wheels starting from the front wheel in direction of movement, and finally width of the axle. This format must be maintained for all vehicle types. More details are available in the help manual. Why it is helpful and how we can use this for moving load analysis? Check this file that I have created for different types of crane. Depending on the crane capacity, span and distance of wheels, wheel load is calculated for each case, and that data along with all distance are included under a separate category. For any model, I can import this external loading file, select the required crane capacity from the drop-down, and that's it. Program will read the file and collect the load data. Also, we can easily multiply the vertical load by a factor. It's easy, right? If any load information varies from the predefined crane data, we can easily open the text file, modify the data, or create a new category with updated data. If we use similar type of load data in multiple models, then it is always better to keep an external load file. This will minimize the modeling time. Note that we need to keep this file in same folder where the STAAD file is located, else program will throw some error message. With this, vehicle definition is complete. Now we need to inform the program where to place this load on the structure, direction of movement, and distance interval. For that, we can use moving load generator. That I will cover in my next video. Stay tuned.